you know.
I do some basic stuff like it's like container, the very install, like the whole thing. I know some basics.
All right. Okay, so this presentation is a basic introduction about Docker. It's not a very advanced level. I just want to introduce some basic concept about Docker and how to use Docker, what kind of problem we can solve with Docker, and some commonly used commands to run Docker container, or how to build the Docker image, how can we share the image with others, and how can we pull, how can we push this image, and how can we reuse those images. So, those kind of basic things I will talk about the Docker. In today's presentation, it's not very advanced level, just some basic introduction. Okay. So today I will talk about what is Docker, basic concept about Docker, and why should we use Docker, why not virtual machines, what are the benefits of using Docker instead of virtual machines. Then I will talk about Docker container, little bit about Docker container. So this is the main concept about Docker, the container things, and then I will talk a little bit about Docker image and benefits of using Docker, and finally I will show you some command, how to use Docker, how to build Docker image, how to push and pull to the Docker Hub, those kind of things. So just to get you started on Docker. So Docker is currently a buzzword in the current IT industry. Everyone talks about Docker, and this technology is not very old. The first release come in 2013, I guess, the first version. And the founder of Docker is Solomon Hayek. He's a French guy. He started working on Docker while he was working in France in a company. Then some other engineers joined with him. And then the first release came on 2013. So it's a new technology and little bit different with the currently available virtualization software we have. So the concept is little bit different. That's why maybe it might be a little bit difficult to get the concept at first, but whenever you get the concept, then it's not that much difficult. Okay. So why should we use Docker? This is the problem we want to solve. So I think most of you guys have faced this problem, that this code works on a machine, but it doesn't work on the production. And that software works on my colleague's machine, but it doesn't work on my machine. So all of us have faced this kind of problem. And the reason behind is that the development environment in our machine and the production environment is different. Most of the time it's different, like where many of us are working on Windows, some of us working on Mac, but on the server side, mostly we are using Linux. Linux distribution. In Pipe, we are using Red Hat. It's a distribution of Linux. Some might use Debian or Ubuntu, something like that. So only the operating system here is the big difference. In the server is Linux, but here we are using Windows. So this is big difference, and there are some other differences too. Maybe we have Python version 3 on our own machine, but on server they're using Python 2.7. So there might be some versioning problems, some other difference might be we have different virtual environment variable in our machine, but environment variable is different in the server too. So those kind of things can create the problems. That's why sometimes it runs in our machine, but it doesn't run in the server or in someone else's machine. So the primary use of Docker is that we want to solve this problem. There are some other solutions, like we use VirtualBox and Vagrant here in Trex. But the Docker is the new solutions. There are some problems using VirtualBox and Vagrant. I guess many of you have faced a lot of problems setting up Vagrant and environment, right? So how many of you face difficulty setting up your background? All of you are. Okay. So, because I also faced this kind of problem. When I came into Trex first, then it took me about 2 days to set up my background environment. So there are a lot of things, installing my VirtualBox, configuring my background, downloading the box file, and all of those things. And finally, it looks like it doesn't run. Then what's the problem? Then debug those things. So what is the problem? And it takes a lot of time to set up everything. For example, Ramsey is also suffering from setting up your background environment, right?
Yeah.
So you are working on that for the last 2 days.
Yeah.
But you still have problem with that. So Docker can solve this kind of problem. So all those whole things like setting up your background environment, downloading your box file, setting up your environment variable, setting up your Python version, setting up your virtual environment, all those things you can solve with Docker with just one line of command. So if you have the Docker image in your repository and you just run Docker run, then the image name. And if you have Docker installed on your machine, then that software will run. It's guaranteed that that software will run. And it can be run only with one command. So that's the best thing I like about Docker is that, it just works. Okay, so in the definition of Docker, I put this line of words is that it just works. That's the most beautiful thing about Docker. If you build it once, then whatever the platform is, either it can be Linux, Windows or Mac, Ubuntu or Red Hat, anything. If your Docker container run on your machine, it can run anywhere. That's the good thing about Docker. So you don't have to take all those hassles, setting up your environment, your virtual machine, your background, nothing else. So the official documentation of Docker is that Docker is an open source project to pack, ship, and run any application as a lightweight container. And the container, it doesn't only include the source code. The software you are building, the code you are writing, not only that code or that software, but the container includes everything that needs to run the software. I mean, all the dependencies. If your software depends on Python 2.7, if your software, if you're running Django 1.10, if your Django depends on Celery, if your Django have dependency on Postgres, or if you're running RabbitMQ or Redis, that kind of messaging server or anything. So whatever is required to run your software, container will include everything and it will package in a single container, and then you can share that container to others. So what does it mean? It means that you are not only sharing the software or the piece of code to others, you are sharing the whole environment. So whenever someone is trying to run that software, he's getting the piece of the code and also whatever is required to run that software. So it's guaranteed that he will get exactly the same environment you are using in your own machine. That's why it's guaranteed that it will run everywhere. It can run on Linux, it can run on your own machine, it can run on AWS, it can run on Microsoft Azure or anything, any kind of hosting service. Okay, so to learn about Docker, the idea about Docker, the best thing is to compare Docker container with the usual virtual machines. So here is the container on the left side, and here is the virtual machine that we are using in Trex. So in Trex we are using background, but in the background is also using the virtual machine, the Oracle VirtualBox. Okay, so background is just to manage those virtual boxes. It's a software to control your virtual boxes. but in the background, we're basically using these virtual boxes. Okay. So one way to solve the problem of it works in my machine is to use the virtual box. So what this virtual box is basically create another machine in your own machine. It has its own operating system. It has its all the binaries and the libraries which is required to run that operating system, and on top of that you have your applications. So so here's the infrastructure at the bottom of that image. So this infrastructure is our own machine. Then the hypervisor is a kind of Microsoft product. Is basically is responsible for running your virtual boxes. So Microsoft has released their new virtual box managing machines, which is called Hypervisor V, which comes with Windows 10, but we don't have that Hypervisor V in Windows 7 or anything. But that part is responsible for configuring your virtual boxes. So on top of that, we have our virtual boxes, which is the Oracle virtual boxes we're using. And every virtual box has its own guest OS. That means it has its own operating system. So in our virtual boxes, we are using the Red Hat, that Red Hat Linux version that we have in our pipe environment. So remember, when you configure your background, you have to download the box file, right? So inside this box file, it has all the required software and all of the dependencies that is required to run your Python Django applications in pipe. Right, so this is basically a replica of the pipe environment. So whatever is in pipe, the Red Hat Linux distribution, it has then the Python 2.7 or Django 1.10 or everything that is required, that is in the pipe, you have it in your virtual boxes. So this is basically the structure of virtual machine, virtual boxes. Then what is container? What is Docker container? What's the difference between the virtual box and the Docker container? So if you look at here, so the basic difference is here. So we have our infrastructure, then we have our host OS, the operating system we have in our machine. It could be Windows, it could be Mac, or it could be Linux. Then on top of that, we have the Docker engine. Then on top of that, we have different containers, which is running application A, application B, and application C. So if you look at those two images, the difference is that container doesn't have its operating system. So this is the concept Docker is using, is that it doesn't require its operating system. When the virtual box, it requires its own operating system. So why Docker works like that is because Docker is built on top of the Linux kernel. So it runs on the Linux kernel, and the good thing about Linux kernel is that most of the Linux version, it could be Red Hat or Ubuntu or Debian or anything, they use the same Linux kernel. The only difference is that some other library files or the binary files. So if you have the Linux kernel on your machine, you don't need to have operating system to run each of your applications. That means to run your application A, you don't need a separate operating system to run application A. Same thing with application B or application C, because all those applications, they can they are running on top of Docker, and Docker is using the Linux kernel that is present on the host operating system. That's why it's not using the whole operating system for every applications. That's why it's very much lightweight compared to virtual machines.
Does the Docker have its own operating system?
No,
So
but it needs Linux to run.
So does it convert the host operating system to the Linux, or does it just ignores it?
No, if for example you are running on Windows, then if you want to run Docker, then you need a Linux operating system on your Windows machines. Then Docker will run on top of that Linux version. Then again, all other container that doesn't need any other operating system. It will work on that Linux versions. Okay, so Docker has built. Any other question?
So like then on a Windows machine, then you would still have to virtualize a Linux machine?
Yes.
And then run Docker inside the virtual machine?
But if you are running on Linux, then it doesn't need to install any other operating system. It can directly run on your machine's operating system if it's Linux. Because Docker depends on the Linux kernel, so it needs the Linux kernel.
Right.
Any question, Olga? Do you have any question? So I think the idea of container is a little bit clear here. So the basic difference is that it doesn't has its own operating system, whereas the VM has its own operating system. So that's why the difference between virtual machine and the Docker. So what advantages we have using Docker on top of the virtual machines? First of all, the VMs are very large because it has its own operating system. The operating system alone can be about 1 GB. So the normal Ubuntu or Red Hat distributions, it might be 1 GB. So only the operating system, it might be 1 GB or hundreds of megabytes. On the other hand, Docker, it doesn't use the full set of operating system. It just uses the separate binary files or the libraries that is required. So on the other side, Docker container, it will be maybe 100 or 200 megabyte. So it's very light in size compared to virtual machines. And again, the second thing is the performance. So since VMs is running a complete set of operating systems, it requires a lot of processing power. And it takes a lot of memory from your host machines. So on the other hand, Docker doesn't require that things. And the portability. So the portability, I like this feature most because this thing is one part of portability is that you can run Docker anywhere on your local machine, on Linux server, on Windows, on Mac, on AWS, on Azure, on anything. But VM, if you want to run VM, you have to set up the VM on every machine. So you have to configure the VM. And another thing about VM is that, let's say you have more than one VM in one host machine, then it's very difficult to communicate with one VM with another VM. There is no easy way to communicate with each other. But on the other hand, Docker can easily talk with each other. If you want to make talk one Docker container with another Docker container, it's very easy. You just have to run some simple commands, then this container will talk with that container. For example, let's say you have one Django applications, then you can run your Django applications in one container, and then you can run your database in a separate container. You can run your Celery in another container. You can run your Redis in another container. Then all those containers can talk with each other. So this is very easy to communicate with each container. And the advantage of it is that you can really keep your application separated. So for example, we don't really change database oftentimes. Changing the database is very late. So if we keep the database separate in another container, we don't have to touch that container. It's totally separated. Then we have the Django applications in another container. Then these Django applications can talk with that database in a separate container. So this is another advantage of Docker is that you can really keep your applications isolated and separated. So for example, let's say Ramsey is working on database. So he can work on one container. I'm working on Django. I can work on another container. Another guy, maybe he's working on another part. Let's say Redis or RabbitMQ or anything. So he can work on that container. So nowadays, it's not like that one application, the environment will be same for every part of that application. So most of the applications nowadays is that it is like, it doesn't use the single stack. It doesn't only use the Python. Maybe some part of that application is using Java. Some part of that application using Go language or anything. So what can we do? We cannot really run Java and Python at the same machine. So what can we do? We can create separate container, one for Java, one for Python, and we can let them talk to each other. Then they can communicate with each other. So these are the advantages of Docker. There are so many other advantages of using Docker. These are the basic 3 things. Okay, so I already talked about Docker containers. So to understand container, so let's look at a physical container. So on the left hand side, this is a physical container. Let's say you have a shipping company. You need to transport some various kinds of goods. Example, you need to ship one car. Then you need to ship some coffee beans. You need to ship one piano. You need to ship some wines. So how can you do that? So if you try to ship all those things together, then what can happen? Let's say your wine barrel is leaked and all the wine is spilled over piano. So that can create problems. So then the container, we have created the container. What's the use of the container is that we can really separate those things we need to ship. We can use one container for our car. We can use one container for our coffee beans. We can use one container for our piano. We can use one container for our wine barrel. So if you keep them separated, so there is no possibility that they will create problem. One good will create problem with another good. So they are in the separate container, and then we can easily ship that container to other places using ship or using truck. And another good thing is that we can stack one container on top of another container, right? So this is the physical analogy to understand the container. And Docker container does the same thing. So here, instead of car or piano or the wine, we have different app. So we have created different container for different app, and then we put all the dependencies and the applications and all its dependencies in a single container, and then we can ship that container to other places. So when someone else gets that container, he gets the code, he gets the source code and everything that is required to run that software, right? So we can ship that easily to other places, and since it has every dependencies, including the source code, then it can run anywhere. So this is the official definition of container. A container image is a lightweight standalone executable package of piece of software that includes everything needed to run it. It includes the code, it includes the runtime environment, it includes all the system tools and system libraries and settings. And as you can see from here is that every container is built upon on top of the kernel. This is the Linux kernel, and you see the container, the leftmost container is running Java with a Tomcat server, and it's on top of the Debian distribution of Linux. So here Debian means it doesn't mean that it's the complete set of Linux. It's the separate library or the binary files that is only specific to Debian distributions. And the main thing of Linux is behind it is in the kernel. So the heavy lifting is done in the kernel, and only the specific binary or the library file is on the Debian version. Same thing's happening on the container on the other containers. It's running the SQL Server or .NET applications, and another one is running static binary and Alpine distribution, those kind of things. So any question about container? Because container is the most important concept to in Docker. So if you understand container, then half of Docker thing is done.
So Docker is made up of a bunch of containers. Is that?
Yeah.
Okay.
So
what?
Docker
So like,
is basically the whole thing, including the container, the whole ecosystem,
okay.
including the Docker engine, including the container, including the Docker image and everything.
Okay.
Container is just a part of Docker, which includes everything to run a piece of software.
So there's not really anything to compare a container to when using like our VM or Vagrant?
Yes.
Because it sounds like you're putting a specific application,
Mhm.
but we don't
So
really
the
do that.
Basic difference of VM and container is the OS. Because every VM has its own OS, the operating system. But Docker container, it doesn't have its own operating systems.
But it would be like if you were running a separate Vagrant installation for every different app. That would be analogous
Okay.
to having a different container
Okay.
for every app.
But you said you still need Linux to run Docker?
Yeah. You need, if your own machine is running Linux, then it doesn't need another Linux.
Okay, but so like say my machine right now, I have that Windows,
Yeah,
right?
So if you're running on Windows, then you need a Linux kernel to run Docker.
Okay, so it's
That's
basically
only
the
operating
same
system.
size then, right? Because
No, it's not same size.
It's not?
Because when you're shipping the container, you are not shipping the Linux. Linux is on your machine, okay? And the Linux is the Linux kernel that is required. So for example, in your server, if Docker is installed, then it also has the same Linux kernel. Okay, the Linux
Okay.
kernel that you have in your machine, the servers also have the same Linux kernel because the Linux kernel is same for every distribution, either it be Red Hat or Debian or Ubuntu, anything. So that part is same for everyone, but the other things, what are the other differences, the other dependencies, you are sending, you are packaging all those things in a container, then you are sending that container to them. Then it's running again on top of that kernel.
so it sounds like it's not as flexible as a virtual machine then, because it's requiring everyone that you're sending the container to have Linux on it, right? But like a VM, I can just send, because if the OS was already packaged in it,
Mhm.
then I guess it seems like a VM is easier to kind of distribute than a
No, the basic difference is here is that you need to configure your VM, right?
yeah.
Like you need to configure your background. You need to download the box file. You need to configure the VPN to run your environment. Right?
So an interesting thing about our environment here is that the pipe team is kind of responsible for configuring all the VM stuff to make the virtual machine and look exactly like a production servers. So how does like this whole scheme fit, I guess, in our development cycle at the university using like the pipe environment? Because when we deploy all our applications, we're deploying it onto like a pipe-like environment, which has all the dependencies that our virtual machines have. So then if we were deploying our new applications, and we would just be deploying things to a Docker instance being hosted somewhere on ITS?
Yeah, it could be something like that. The pipe team, they can build one base image, which will, let's say you are working on Django and Python. Okay, so they will have their base image, which includes the other things like the authentication systems, and that is very specific to UT systems.
Like
so
Broadband.
that base image could have those things. Then you can take that base image, then you can run, you can build your own application on top of that. Then you can build your image on top of the base image. So it will include everything from the base image. Then you build your own image. Then if you send your own image to the pipe team, they can just run it from the repository. Then it will run in the server because it already have everything that it was to run.
Yeah, let's
Okay,
see.
and
Sorry.
and if it runs in your laptop, it's guaranteed that it will run in
Gotcha.
server too. So in the current system, there is good, but still there are some problems. Like for example, a few days ago, I was trying to deploy my Django applications on pipe. Then this time I used the latest project structure, and then it was running on my machine, but again the same problem. It was not running on the pipe server. Then I sent them a mail, what's happening here, because it's running here, why not? I'm using the background, I'm using the VirtualBox, same environment, but still it's not running there. So what was the problem? Then they said that, okay, you can't have the init file on the project root.
Gotcha.
That's how their they are differentiating if it's a newer version of project structure or this is the older version of project structure. So if you don't know that this is the rule they are